Hi everyone, it's nearly 1 a.m. I'm shooting this video, so I'm not going to discuss very important things. Yeah, what I'm going to discuss is to some extent important but easy things. I thought of discussing Sylvester theorem, but let me do it in some good time. It's nearly 1 a.m. So let me do I will teach you some of the types of matrices today. This is important, okay? For basic concepts they are important. Like symmetric matrix, skew symmetric matrix, Hermitian matrix, skew Hermitian matrix or anti-Hermitian matrix, unitary matrix, involuntary matrix, idempotent matrix, periodic matrix, nilpotent matrix. There are various type of matrix: diagonal matrix, upper lower triangular matrix. I have already gone through this, and scalar matrix, and many more. Okay, so what is important from here is unitary and Hermitian. There are some problems from Hermitian nature. Symmetric is also important. Also, we're going to you people have to memorize some examples, some 2D examples of some kinds of matrices. Sometimes they will ask some of the properties and you need to work on them in exam. I will discuss this. You will not understand from my words what I'm trying to say. Okay, so the chance think it's not very good for this red. Okay, so first is symmetric matrix. Symmetric matrix. What is symmetric matrix? Suppose there is a matrix A. If it equalizes its transpose, it is known as a symmetric matrix. Okay. For example, zero 3 3 0. What is the transpose of this matrix, my dear friends? Obviously 0 3. This column will become row and the row will become the column. That is transpose. So this satisfies. So it is a symmetric matrix. Remember one thing: identity matrix. If you find the transpose, this will become this, and yeah, this is also symmetric. So remember one thing, that an identity matrix is always symmetric. And let's go to the next page. What is skew symmetric matrix? Skew symmetric matrix. A is equal to minus A transpose. Okay, this minus is important. This makes skew symmetric matrix. Okay, so example, let me take 0 minus 3 3. Let me do the transpose. The transpose is, this will go this side and this will come down. Let rows become columns and column becomes rows. So what can we say? If we just multiply this thing with minus sign, this will become plus, this will become minus. That equalizes this. So we can conclude A is equal to minus A transpose. Correct? Okay. Easy, no? Next example. Let me see what I can do. Okay, orthogonal matrix. If there is a matrix A, if we multiply it with its transpose and this gives identity matrix, then the matrix A is known as orthogonal matrix. Orthogonal matrix. Okay, fine, fine. Okay, now the most important thing, listen this very carefully. Hermitian Hermitian matrix. ठीक है. So what is Hermitian matrix? Hermitian matrix has a very unique property. Okay, so Hermitian matrix, suppose there is a matrix E and it has complex conjugate terms. I repeat, complex conjugate terms. That is, okay, let me first define it. Suppose we do the transpose of this matrix first. What we do? Transpose operation. Transpose. Okay. Then we do the complex conjugate operation on it. That is, if there is something I, we make this minus I. Suppose there is 3i in one term, we make this minus 3i. That is complex conjugate. So you can do anything first. There is no order that you can first do the transpose and then the complex conjugate, or you can first do the complex conjugate and then do the transpose operation. It's your will. So this thing is, if A equalizes this thing is written as A theta. I write this theta, many people write this as dagger, like this sign. I prefer this sign, so I use this. It's your convenience what you people are going to use. So we can write a Hermitian matrix A is equal to the transpose and complex conjugate of that matrix, which is written as in this way. Let me give an example. Suppose you have this matrix. Okay, what you people need to do? You people need to make it the complex conjugate operation. Let's do the complex conjugate operation. What you need to do? Suppose this is A. For complex conjugate, I'm writing in this way. You have 1 minus I plus I 0. Okay. If you do the transpose, you will have 1 plus iota minus I or iota, whatever you say, 0. See, this and this are equal. So this is a Hermitian matrix. A equal to this in this case. So this is a Hermitian matrix. Okay, so there are some properties of Hermitian matrix that may be directly asked in your MSQ or MCQ exams. These are that entries on the main diagonal are always real. Remember this. See, this is known as the main diagonal, this side, and the terms are real. This can be extended to 3 dimension as well. And please remember this standard matrix. I am giving you the examples because these are very important. बहुत रात हो गया है. I'm going to finish this video and going to make the power in the next video. Okay, I'm there for 10 minutes, 5 to 10 minutes more. Let me make you understand more properties, whatever. So the properties are the entries on the main diagonal. The, kindly note it down. The entries on the main diagonal are real. The entries on the main diagonal are real. Next point, first let me write and make you understand that, no issues. The entry, let me pause and write, okay, this will, okay, लिखना हो गया. So let me explain. The entry aij in the ith row and jth column is the complex conjugate of the entry iji in the jth row and ith column. Hope you don't understand anything after reading this statement. Your professors and the professors will get in future after cracking this exam will just tell this line and leave. So I don't support this, so I'm going to explain you this. What is this? The entries on the main diagonal are real. You have understood from this example that, yeah, I have explained this, right? If you have any problem, feel free me to ask. So the entry in the ith, I have written many things. I'm telling you what is that. See, this is actually A11. This is A21. You know the matrix form is written in this A31. This represents the third element in the first row and nothing. That is first the column, then the row. Am I right? Yeah, right. So, and this is A21. This is A, sorry, this is A, yeah. A12, right? 1 minute. Yeah. First element, first column, row. Okay, let me drop. Can I drop it? Yeah. No need to worry. First column, second row. Again, that is row CR7. Football, I think I'm not a very great fan of football. I've heard this, whatever. CR7 is who? Neymar, no? I don't know. If I am telling wrong, sorry for that. If there is any football fan watching my video, pardon me, please. Whatever. So, 1, 2. Again, second column, second row, A2. So, what I am trying to say, this I know you know, but who have forgotten, I am explaining for them. You can make the video in forward direction, 10 second. What is the YouTube algorithm? You can follow it, whatever. 1 1, that is, this is 1 2, this is 1 3. I am restricted to 3 dimensions. You are in BSc, you don't need infinite. Actually, you will find that in quantum if you read advanced, whatever, leave it. A21, A22, A23. This is A31, A32, A33, right? That is, this is the column, this is the row. So what is A31? No. This is the row, this is the column. Now I think I am correct. Yeah. This is the first row, this is the second row, this is the third row, this is the first column, this is the second column, this is the third column. Yeah, I am correct. Sorry, that will be RC, not CR7. RC. Sorry, extremely sorry. So तो ये है रिप्रेजेंटेशन, ठीक है, आप लोग ये जानते हैं. सो A11, A21, this is A12 and A22. What is written in the statement is that what will be the value of A21, that is Aij written over there in that statement. If you have written, you can see the A12, that is Aj will be the complex conjugate of that. See, in that example here it is I for A21, but for A12 it is A, it is minus I, minus iota, that is complex conjugate form. So this is written there and nothing else. Okay, and the most important property, sometimes it can be asked in very good exams like NET or GATE, and if people are preparing for JAM, here it can be also asked, that is the eigen values of a Hermitian matrix are real. This is always true. Okay, remember, this is very important property. You will need this in future as well. I repeat, the eigenvalues of a Hermitian matrix are real. You can find the eigenvalues. The example I have provided you from this matrix, that is 1 iota minus 1 minus iota 0, this matrix. You can prove it easily that you are getting real eigenvalues. Okay, this is very important property. Okay, now let me teach you what is skew symmetric matrix. Skew symmetric matrix, no, sorry, I've taught you what is skew symmetric. This is skew Hermitian matrix. I'll never make video in this time. It's, what's the time? Okay, 12:54 a.m. Skew Hermitian. Skew Hermitian is just opposite of Hermitian. In Hermitian, we people are getting A is equal to A theta. In skew Hermitian, you get A is equal to A minus theta. Okay, and the properties are opposite to Hermitian. Okay, let me define what is unitary matrix. You get what is orthogonal matrix. A and multiplication with it of A transpose equals to the identity matrix A transpose equal to iota, I identity matrix. And in unitary matrix we just take the property of Hermitian, that is A multiplied with A theta equals to identity matrix. This is unitary matrix. For example, the example of a unitary matrix is this one. Remember this, I am not proving anything. 1 root 2 1 upon root 2 I root 3 iota. Something I'm telling it is I, something iota. You can use whatever. Actually, it's iota. But people usually say I. Iota is a different language. Whatever, it doesn't matter. A theta equals to I. Okay, you can prove this. Okay, prove this as an exercise. You know matrix multiplication. Just do the transpose operation, then take the complex conjugate, proceed. Okay. Okay, I forgot to give you an example of Skew Hermitian, what happens is skew Hermitian, just you know the example of Hermitian, right? I wrote here where it is, this one. Just multiply iota with this matrix. The example you get after multiplication is skew Hermitian. I mean, this product you will get after multiplication of this Hermitian matrix is skew Hermitian. So do it in your own. It's a very easy thing. I'm not doing that. It's IA, where A is Hermitian. Okay, easy now. चलो ठीक है, तो यूनिटरी हुआ. अब नेक्स्ट में हम क्या करें, चलो. और कुछ मैट्रिक्स है, मैं उतना एग्जांपल आप लोगों को नहीं दे रहा हूँ. Just I'm going through the matrices. They are not so important, just remember the properties and their names. That's more than enough. E square is equal to A. This type of matrix is known as idempotent matrix. Idempotent matrix. Okay, next. A to the power k plus 1 is equal to A. अगर ऐसे हुआ तो इस टाइप ऑफ मैट्रिक्स को हम बोलते हैं पीरियोडिक मैट्रिक्स. Periodic matrix. Okay. And what is left? यूनिटरी हो गया, और क्या बाकी है? हाँ, k is a number. Okay, after a certain period we'll get back the matrix. Not so important, just remember the properties. That's more than enough. E square is equal to I. This type of matrices are known as involuntary matrix. Involuntary matrix. And I square is equal to I. This is always represent involuntary. Okay, this represents involuntary matrix. I square is equal to I. A to the power k equals to 0. This type of matrix is known as nilpotent matrix. K is an integer. Nilpotent. Two, 1, 3, 0, 0, 0, 0, 0, 0. Where only diagonal elements are present, this type of matrices are known as diagonal matrix. Diagonal matrix. Okay. 1, 2, 3, 4, 5. Oh my god. 4, okay, 4, 6, 5, 0, 0, 0. You know this? What is this? Only upper elements are present in the right hand side, so this is upper triangular matrix. And in case where these elements are, I have done this in my previous video, where these elements are present but these elements are 0, are known as lower triangular matrix. Next, a scalar matrix. This is an example of scalar matrix. Okay, the diagonal elements have the same values. Okay, and nothing is left. There are some properties I will explain you in the next class, some important properties. So a good night for me. I think it crossed 1. Yes, it's just 1, you can see. So it's 1 am. So good night for me, and I know when you are seeing this video. Okay, there is another property important. Let me tell this. If mod of A equalizes 0 and mod of A, that is determinant, is not equals to 0, this type of matrices is known as singular matrix. Singular. And this type of matrix is known as non-singular. Non-singular. Same one. Okay. Non-singular. So when the determinant of a matrix is equal to 0, it is known as singular matrix. When it is not equal to 0, it is known as non-singular matrix. So 0 is singular, 0 is a single number, right? So it implies single number, so it is singular. And not equals to 0 means it can be infinite numbers, so not singular, so non-singular. You can remember in this way. So hope you enjoyed the lecture. It's a little bit long, 25 minutes. So good night for me, and enjoy your journey of learning. Thanks for watching the video. All the best. बहुत पेजेस लिखे हैं, हाँ ठीक है, चलो बाय. Yeah.